Okay. So here we go. We have displaying categorical data. All right. So specifically, we're talking about two graphs that display categorical data only. All right. So categorical data is like, remember, no units, like hair color, what grade level you're in, how, things like that. So categorical data. The first graph is one that you guys probably aren't familiar with. The second graph is a graph that you guys are probably pretty familiar with, okay? All right, so first one, segmented bar graphs. All right, so when to use? You use it for categorical data, and you use it when you're comparing groups, right? Very useful for comparing groups. So if you notice, we're comparing men versus women. I believe this is like how much dance, TV, sports. Okay, I'm not really sure what the topic is for this one, but maybe it is like favorite recreational activity. I don't know. But you can see here that we have bars that represent the relative frequency. And relative frequency is just a fancy way of saying the percent, all right? So for segmented bar graphs, the vertical axis is always, always, always percent or relative frequency, right? So since those mean the same thing. So percent, relative frequency, proportion, those all kind of mean the same thing. So that's what that vertical axis is. And that way the heights of the bars will always be like the same, and that's easier to compare. All right, even if you have a different number of men versus women, percentage-wise, it'll always be 100%. So the bars will be the same height. All right, so then how you do it is you first calculate all the relative frequencies, draw bars representing 100%, and then you divide each bar into segments corresponding to those relative categories, which is why it's called a segmented bar graph, right? So here we can see, about 10% of men prefer dance. And then from 10% to 50%, so that's a 40%, right? So 40% said TV. And then from 50 to 100, so that's 50%, say sports. All right, so actually I can even write that in here. So this is 50%. And this is, I think I said 40%. And then this was 10%. And you can see it adds up to 100. All right, whereas for women, we have 50% dance. From here, this is 50% right here to 80%, so that's 30% TV, and then 20% sports. All right. So really, really useful to, make comparisons. So you can say like, all right, there was a lot more women who preferred dance than to men, whereas for TV and sports, men had the greater percentage. Okay, so really useful way to compare categorical. By the way, this is also a bivariate graph, all right? Bivariate, we have two variables, gender, and then dance, TV, or sports, right? So gender and then preferred recreation. So this is bivariate. All right, so let's go ahead and try to make one on our own. So here we go. We have this question, okay, which is, ideally, how far from home would you like the college you attend to be? All right, ideally, how far away from home would the college you go to need to be away from home, okay, or away from your parents, I guess. So we have students and we have parents. Okay. And then we have these four ideal distances, less than 250 all the way up to more than 1,000. Okay. All right, now notice we have frequencies here. These are counts. To make a segmented bar graph, which is what we're trying to do, we need relative frequency. Okay. So can anybody tell me, let's say if I want to find this one right here, students, I want to find out what % of students said that ideally they would be less than 250 miles away. How would I do that? Any volunteers? Any ideas? What would I need to do first?
You add up all the students and then you take the total And then
Good.
you the students that want to be less than 250 miles away, and then you divide it by the whole
Perfect.
total.
Yes. Awesome. So we have to add up all of these guys. And does anybody have a calculator? Can somebody do that real quick? And then somebody else, can you add up? We have to do the same thing for parents. So just holler when you have it. Oh yeah, sorry, I should have mentioned you should go grab a calculator.
I got 3,007 for parents.
For parents, awesome. Let's see, 3,000, oops, where'd my pencil go?
7.
3,007, got it. All right, 3,007. Thanks, Johnny. And does anybody have students?
I got 12,715.
Ooh, nice. All right, 12,000, what was it, 700?
715.
15.
Yeah.
Sweet. Thanks, Madison. Okay. Let me go ahead and assign people relative frequencies. That way we can just kind of get those numbers to start our graph. All right. So Kira, since you had the students less than 250 all kind of worked out in your head, if you could just grab a calculator, go ahead and give us that first one for students. Let's see, Angelus, can you get the second one for students? Susan, can you get the third one for students?
Like round.
Oh, sorry.
Do you want us to round?
Oh, yes. Good point. Let me see what I have. Let's have you round to 2 decimals.
Okay.
Yeah, thank you. All right, so Kira, Angelus, Susan, you're going to be on this third one for students. Karis, I'm going to put you on the fourth one for students. Matthew, I'm going to put you on the first one for parents. Lishan, you're going to be the second one for parents. Let's see, Nick, I'm going to have you on the third one for parents. And Clancy, I'm going to have you on the fourth one for parents. All right.
About 35%.
35. Okay, hold on. Let me reply to this message real quick. Oops. Uh-oh, sorry, give me a sec. There we go. Sorry, Kira, can you give me one more time?
35.
35, got it. All right, let's see if I can type it. That might be a little better. 0.35, awesome. Okay, and then who was second? Angelus?
I got 31%.
Nice, all right, 31. Sweet. Okay, and then I think it was Susan.
I got 0.19.
19, awesome. And then I forgot.
It was me.
Harris.
I got 15.
15, nice, perfect. And a quick way you can double check, add all those up and make sure it adds up to 100% or 1. And it does, so good job. Okay, parents, I think Matthew, you had the first one?
53.
53, nice, all right. And the next one I think was Lee Shaw.
I got 30.
30%, okay. And this one I think was Nick.
I got 11.
11, awesome. And Clancy.
I got 6.
6, awesome. And let me just double check, make sure that adds up to 1. And it does, perfect. Nicely done, guys. Okay, so that is your step 1, is find those percents. All right, find those percents. And now we can go ahead and graph. So take your straight edge and we're gonna draw a y-axis and an x-axis. Give myself a little more room here. Okay. And then let's go ahead and we're gonna make 2 bars, one for students and one for parents. So go ahead and draw a bar for students and a bar with the same height for parents. All right, now notice guys that even though we have a lot more students, the bars are still the same height. And I think that's just easier to compare, and that's why we use percents. Okay, so let's go ahead and mark this up. Let's go, that's up to 100. And let's go by tens. All right, so I'll mark my 50 here. I'll go 1, 2, 3, 4. All right, then 50, 60, 70, 80, 90. All right, so that will be 100%. And make that a little smaller. Or not. Okay. And then let's go ahead and let's label these. So we have percent. Okay. For my y-axis. And then for my x-axis, I want students and then parents. Let's see if I can move this one out a little bit. Okay. Ideally, I would actually make that percent like vertical. I don't know how to do that on this one, but I would like, you know, go from here to like make it go vertically. Okay, so you guys can write that. All right, let me label my 50 here to make it a little easier for myself. All right, and then now we just need to break up the segments, okay? I think it actually makes the most sense to have the least amount of distance at the bottom and then go all the way to the top to the highest or furthest away. So I'm gonna kind of go from bottom being less than 250 miles to the top segment being more than 1,000 miles. Okay, so let's try this. First, I have the 35%, so I'm gonna mark off 35% right there for less than 250. Okay. And then I'm gonna add on another 31%, right? So since I'm stacking it, I have 35 plus 31, so I should go up to, that's a total of 66 accumulated after that. So 66 is right around here. Okay. And then after adding, so this put together was 66%. All right, and then after that, I'm gonna add another 19. So after I add 19, I'm up to 75%. So 66 plus the 19 gets me 75. All right, so I'm gonna go up to 75%, which is right around here. 60, 70, 75. Oh, did I add that right? Oh, 85, I'm sorry. Yeah, that seemed wrong. 85%. All right, so 85%. And why I said that seemed wrong was because I looked at what was left, which was 15%. So after I make this line, I should only have 15% left. So when I drew it down here, I was like, wait a minute, that didn't seem right. Okay, so that's why I was like, Okay, so those are the segments. Now notice I can't really tell which segment is which at this point. So what I'm gonna do is, let me see if I can, I wonder if this will work actually. I'm gonna try to color code this. So, oh yeah, I can. Okay, so let's make orange. I'm gonna make a little key here. All right, so let's make orange the first one, which is less than 250 miles. Okay. And then I'll make green this one. And then this will be 250 to 500 miles. And let's do blue. To represent 500 to 1,000 miles. And let's do pink. Oh, that's not pink. Let's do pink, there we go. To represent, oh, I made the text pink. More than 1,000 miles. All right. So then that's my key to kind of make, so you know which segment represents what, right? So that's pretty important to have that key over here. So ideal distance from home. Okay. Let's see, maybe even a little bit more. Ideal distance college is away from home. I feel like that makes it a little more clear about, you know, what this graph is about. All right. Any questions up to here? Okay, why don't you guys try the parents graph, all right? So give it a shot and then compare your answer with mine once you're done and just kind of see if you were able to get it, okay? So finish off the parents bar. Okay, once you're done, give me a blue thumbs up and that way I know you are ready. Awesome, awesome. All right, getting some more blue thumbs up. Sweet, good. All right, well, I'm waiting for more people to finish. Let's see. Matthew, which category would you be in? What's your ideal distance away from home for college?
Between the 250 to 500 range.
Oh, awesome. Do you have a specific college in mind, or is just like that distance?
No, because not to brag, but I want to go to like I'm getting recruited, and not all of them are in like California. So just like wherever the road takes me.
Ooh, that's awesome. What are you getting recruited for?
Football and track.
Oh, that's sweet. Congrats. That's awesome. Does the pandemic kind of affect the recruitment?
Like it limits it, especially for track, because they just go off like sophomore because we didn't even have a junior season.
Right.
But they'll set up like Zoom calls and like virtual tours and stuff.
Okay, sweet. I know. Can you just like have a GoPro and like they can like follow you running? I don't know. I don't know how that works. But that's awesome. I'm glad hopefully the pandemic, yeah, didn't affect your recruitment status. Sweet. Let's see. Clancy, what's your ideal distance?
Well, I'm probably gonna study abroad.
Oh,
So,
Or
yeah,
then-
I'm taking like the entrance exam for schools in like France.
oh
So,
gosh, that's
Yeah.
amazing.
yeah, the field that I want to study in, I like got an offer over the summer because I sent in an application. So yeah.
That's so cool. France, Paris is one of my favorite cities in the world. So I love
it.
That's
So we'll see what happens. But if not, then I'm looking at USC too because I didn't have like the best grades over sophomore and junior year, but I also had a lot of like health issues that were like kind of why that happened. And so then I retook all those classes over the summer and got A's and all of it. So then like I have a better chance at getting into the schools I want to go to.
Sweet. Oh, that's so cool. Obviously, I would prefer that you don't go to USC, being a Bruin, but
Yeah, exactly. I forgot you're UCLA.
but that's okay. It is a good school. Is it the best school? But yeah, it's a good school. It's good.
Exactly. So,
Yeah. Awesome. Let's see. Harry, you doing okay? Sophie, you doing okay? Where'd you guys go? Let me see. Where'd Harry go? Oh shoot, Harry disappeared. Oh no, wait, Harry's there. Harry, you okay with the graph?
Yeah.
Yeah? Okay, cool. All right, guys, any questions on making a segmented bar graph? Okay, awesome. What I think was kind of funny was the 180 parents who said, yes, ideally, my child will be more than 1,000 miles away from me when they go off to college. I would love to talk to those parents to see why. Okay, so that is your segmented bar graph, guys. So highlights again, make sure vertical axis, percent, all right? You can have 2 bars, you can have 3 bars, you can have 1 bar. The 2 examples I have here are both 2 bars, and that was just happenstance. But know that you can have as many bars as you want with the segmented bar graphs, okay? And you can have as many segments as you want. Though the more segments you have, the harder it is to read. So gotta be careful there. Things you want to just kind of keep in mind when you make these graphs is always label your axes. So both axes should have labels. And make sure you have a key, right? If you didn't have a key and you just have a pretty looking colorful graph, it'd look nice, but nobody would know what you're talking about. So make sure you have a key and a title, okay? Awesome. All right, good job, guys. So I'm gonna clear this out. Does anybody still need this? Okay, if not, let's go to our last graph. Don't worry about the comparative bar charts. We're not really going to go into that one, so don't worry about it. You can exit out. And let's just go to pie charts. So this is the one you guys are familiar with. So I'm not going to go too much into it. Basically, though, categorical data and useful to illustrate proportions of a whole piece, right? So if you want to know, like, oh, you know, what percent of the whole of parents said that they wanted their child to be more than 1,000 away, a pie chart would be really great. You can see how big of a slice that group is. All right, and I think you guys know how to do it. I know the construction talks about, like, you know, getting the exact degree. Since we're just sketching, you can just eyeball it for this class. All right, just kind of eyeball each slice. All right, let me go ahead and put people on these relative frequencies. This example is about typos on a resume. Okay, so in the near future, when you guys start applying for jobs, you're going to need to build your resume, right? And that's the first impression you have on your future potential employer. And so people asked, I think these were like CEOs, CFOs, how many typos would you be okay with before just disregarding, you know, the candidate for the job? So 60 people, all right, 60 bosses said even one typo and you're out. 54 said 2, 21 said 3, 10 said 4 or more, and 5 just said, oh, I don't know, it just kind of depends. All right, so I'm gonna put people on relative frequency, so listen for your name and then tell me what the relative frequency you got, okay? Here we go. Margot, I'm gonna put you on the first one. All right, and Holly, I'm gonna put you on the second one. Okay, and Ethan Chen, I'm gonna put you on the third one. Billy, I'm gonna put you on the fourth one. And Madison, you have the fifth one. All right, and just tell me when you got your percents.
I did the first one.
All right, Margot, go for it. Oh shoot, I did not hear. Maybe you can type it in the chat. Margot. Okay, I got it, 40%, nice, or 0.4. All right, thank you.
I had the second one and got 36%.
36%, awesome.
I had the third one and I got 0.14.
0.14, got it. Oh my gosh, Margot. Okay, sorry, next one.
I got 7%.
7%, awesome, thank you. And then the last one.
3%.
3%, perfect, good job, guys. Okay, so let's slice this pie up. All right, I'll start with the biggest one, 40%. So it's a little less than half. So I'll draw straight up and then like a little less than half. So maybe like here. All right. And then I'm gonna actually color as I go. Let me see how I can do this. Okay, I'm just gonna oh gosh. Okay. All right, so that's gonna be my first, so one typo. Okay, and then the next one, 36. So Again, pretty much the same size as this one, maybe a little bit smaller. All right, so, oops. So maybe around here. So about the same size, just a little bit smaller. And then maybe around like that much, because this would be like 25%, would be like a fourth. And then maybe add a 10% there. Okay. Again, we're just kind of eyeballing. And let's make this blue. Okay. And that will be 2 typos. All right, another 14% for 3 typos. Okay, so like, like maybe around here. Okay, and I'll make this yellow. Okay, and then the 7 and 3. So 7 is more than double the 3, so I'm going to make that piece more than double that remaining piece. Make that green. And let's do last one, purple. Okay. All right, 4 typos, and then 5 typos. Okay, and all right. So pie chart, okay? The only thing is at the end of my graph, like once I'm done, I always ask myself this question, which is, if somebody were to just look at my graph, would they be able to understand what was happening, right? Can they just look at my graph and know exactly what's happening? And at this point, I would say no. I don't think somebody off the street can read this graph and know exactly what's happening, because you just see 1 typo, 2 typos, 3 typos. Like we don't, oh, whoops, that shouldn't be 5 typos. Sorry, that should be 4 or more typos. And this should be don't know. So yeah, somebody coming off the street, they would not know what's happening with this graph. They just know it's about something about typos. So I would say something on the side or as like a title. I would say number of typos tolerated on a resume. Okay, so that title now gives the graph a lot more context, and somebody off the street can read it and be like, okay, I understand more of what's happening. Okay. The last thing you can do to improve this is, if you wanted, and it's completely optional, but if you wanted, you can even write in the percents here, because we're eyeballing. It's a little difficult to compare the percents. So if I wanted to make this graph even better, I would write in those percents to help whoever's reading out even more and you can get a better comparison. And same thing on the segmented. You can write in those percents in those segments. All right. Sweet. Any questions, guys, on these graphs?